Right. So in this devlog, we're going to prepare a data set for trying out or determining the performance of our neural network model in the form of an autoencoder. So again, the data set that we'll be using will be the omniglot dataset. Okay, and the idea is we want to perform an experiment wherein we'll train an autoencoder for character 1, another autoencoder for character 2, 3, and 4, and then sort of see their accuracy in terms of being able to classify one over the other, or how well does the autoencoder reconstruct character 2, for example, using the weights trained from the character 1 autoencoder model. So ideally, it should have a large distance from character, at least for the large error, I mean, for that represents the reconstruction accuracy from using an autoencoder for character 1 to a sample from character 2. So the first thing I'll do is I'll have to partition my data set into training and validation. Right, so in my directory here under data, I'm going to remove this first. I'm going to create another directory called Magi. Okay, Magi will be the characters of the Magi, of course, and within it a directory for train and a directory for test, or for my validation test. Okay, so the idea here is that for training, I'm just going to use the first 15. Sorry about that. Just going to use the first 15 characters or samples for training, and then the last 5 for testing or validation. Okay, so for my test, I'm going to create a folder here. I'll just call it 1. Then I'm going to transfer them Magi test 1. Right, and then of course in train it will also have a 1 directory. Okay, where I'll copy the last 5 characters. Okay, for 1. Okay, so I should be able to do it the same way for 2, 3, and 4. But in this case, or rather before I do that, okay, so I have my training samples here. What I'd like to do is I'd like to resize these images into a 25 by 25 image. So I'll have an input of 625 features where I treat each pixel value as the feature of that particular image. Okay, so 2 things we have to do first. We have to resize all these images, and then we have to create a vector of features for each particular sample. And let's start with the image part. So I've been working on this resize script. Okay, it's a very, very simple bash script that makes use of Mogrify, which is a tool from the ImageMagick software that will allow me to resize a particular picture. Okay, so that picture will be based on a tube, or rather based on a certain dimensionality that we passed in the command line. Okay, so the way the script works is that $1, the first argument in the command line after the name of the program, will be the location of the pictures. I'm going to loop through that directory and then resize according to arguments 2 and 3. Okay, and it will resize that file and represent it as a new file. So for example, if I'm inside data Magi train 1 and I call the resize script, okay, it would look something like this. I'm gonna run this resize. Okay, so I'm gonna navigate to my directory and data Magi train first 1. Okay, and I'm going to make it a 25 by 25. Okay, so second and third argument, 25 by 25 dimensional image. Okay, I think I mixed it up. So yeah, this test should be the one in. Actually, I can rename this. Instead of train, I'll just name this validate. Okay, and then for test, I'll name this train. Okay, so remember the train directory will contain the train directory will contain the 15 samples, while the validate directory will contain the 5 samples. Yeah, actually, I can now rename this to test. Okay, test. Okay, now we have test and train. Okay, so I'm gonna do the same thing for train. For test rather. Well, now it's for train. Okay. 25, 25. All right. And I'm going to do the same thing for test. Right. So if you take a look at the images here, they're now resized to 25 by 25. Okay. And then the next thing we'll do is we'll convert. Okay, remember this this tool here, so it accepts an input directory and then an output file. So that would be for the okay, what I'll do here is I'll say images and I'll say train. I already have train. Actually, yeah, make use of this directory. So what I'll do here is my input directory will be, of course, the location of 1. That will be Magi train 1. Okay, so that's my input directory, and my output file will be data Magi train 1. No, not train. 1.csv. Right? So it will get stored. So all the images found in train 1 will be stored in a file or will be converted to a vector data under Magi train 1.csv. Okay, same goes for test. Test1.csv. Okay, let's just take a look at it. Okay, so you have 1 the directory and 1.csv. Okay. So those are the values right there. Okay, so once we have that, then the next thing we'll do is we'll do a bit of modification in our code. Okay, in terms of saving the weights. So initially, when we created the weights, we just saved the weights, the weight matrices under a key called weights. But however, I'd also like to store the parameters of my training. So for example, I'd also like to store the topology, which is this topology. Right. Just double check. Right, which is a vector of ints. Okay, aside from that, we also have our learning rate, momentum, and bias. Okay, so learning rate, this learning rate, J momentum, this momentum, and bias. Okay. So just so that the parameters for training are documented. Okay. So let's try this out. I'm gonna do just one run for this one. Okay, so I'm gonna make a config for train. Okay, I'm gonna use a simple architecture. So it's just 625, 200, 625. I have the learning rate, momentum, and bias right there. For my training data, that would be under data, Magi, train, 1.csv. Same goes for the label data because we want to train an autoencoder. Now for the weights, the weights can just be 1.json. Okay, so I'm going to try this out. Config train.json. Oops. Should be train rather. Okay, so it's correct. We have 15 right there. Okay, it's gonna go train for an epoch of 100 iterations. Okay, before it writes the file. So I'm gonna cut the video here and then wait while it finishes before I start the next segment wherein we examine the output of the JSON file. Stop it right there first. Right, so we're now done with the training. Okay, after the 100th epoch, we now receive an error of 6.28166. So if you actually check out the the weights that were generated, so you have the weights right there. Oh, okay, forgot to include one thing. Forgot to recompile it. Weights. G. Try to let's just have it for just 5 rounds. Try that again. I don't think it compiled properly. Okay, so we train it for 5 rounds. And 1, 2, 3, 4, 5. Right, so check out the weight file. Right, so now we have the parameters right here. Yeah, so we're gonna do the same thing for the second data set. Okay, so we're going to say something like resize. Actually, we're first going to put all the images inside 2 for train. For test, 2 as well. Okay, so we'll start with train. We're gonna put the images from character 2 in at least the first then, okay, so this is the process. We copy the images, paste it in directory 2 for train, paste it in directory 2 for test for the last remaining 5. Okay, and we're gonna use our resize tool, or resize script rather, okay, to change everything in train 2 25 by 25, okay, and everything in test 2 25 by 25. After we have that, then we convert the everything in test 2 to data test 2.csv, and everything from train 2 to train to 2.csv under the train folder. So we'll have something like this, right? 2 for those images, 2 for those train images. Right. Okay, so for example, we have the same architecture, but if you want to do it for, if you want to create an autoencoder model for 2CSV, then we have something like following: 2.json, save to a file 2.json, 2.csv for the input, 2.csv for the output as well, and run it using the same parameters, of course. Okay, that's different weights to learn different features from those two datasets. Okay, this will yield 1 to .json. Okay, so these JSON files will serve as the autoencoder model files for character 1 and character 2, and then we undergo some tests for it. Okay, so just to summarize, what we did right now was to modify the save weights function to not only include the weights, but the parameters used to train those weights, such as the topology, learning rate, momentum, and bias. Okay, we have an extra line right there. Okay, afterwards, we had a simple script called resize.sh, okay, which accepts a directory and 2 more arguments specifying the dimensionality of the image you want to resize, and for each file inside that directory, it will resize that file to be according to that dimensionality. So what I'll do right now is okay, one more thing before I commit. I'm going to add a readme file. Okay, let's say installation. Let's say something like run cmake dot and then cmake, or rather make. Okay, just a simple readme file. Of course, I'll be including others as well. Probably something like usage for the autoencoder, usage for training. Okay, so we'll have something like okay, so you run train and then path to config.json. Same goes for autoencoder. Autoencode, classify, path to config.json. Just a simple readme file to get things started. Okay, so I'm gonna create a new gist. I'm gonna create a new gist. Right, so this will be resize.sh, which will be the, say, simple tool to resize all images in a given directory. Okay. I'm just gonna copy this entire thing. public gist. Okay, there's our simple resize gist right there. And of course, commit our code. Save training parameters with save weights and initial readme. Right. Okay, so I guess that's it for. Let's verify. Right, so we have that. Right, so I guess that's it for now for the right. I guess that's it for this video, for this devlog. Probably in the next one, we're gonna run through everything. So by the next video, there should be an autoencoder file, or an autoencoder model rather, for the 4 characters and run it through some results and save the results.